Now we're going to finish up by doing the slope, equation of the tangent line, and horizontal tangent lines, but with functions that are transcendental. So you might have cosine, sine, or the e to deal with. But the process is going to be the same. When you see that they need the slope, you should be thinking, a derivative is the same as slope, so I need to get the derivative of the function. Derivative of cosine is negative sine. Derivative of constant would be 0, so the derivative turns out to be positive 2 sine t. Now you need the slope at the point pi comma 7, so all you're going to do now is plug in pi into that formula you just, here, let me just do it right here. Plug in pi into the formula you just did. So you're getting a specific, not the general formula to get the slope anywhere on the curve, but the value of the slope at a specific spot, okay? And then when you're doing that one, got to think about when you're over here at pi, that's where pi is located, the sine would be 0. So this one, the slope at the point pi comma 7 would turn out to be 0, which means you'd have a horizontal line at that spot. Okay. Now, with 26, the function we've got is a e to a power. So the derivative for that would be negative 4e to the x. Now I'm ready to do the slope at this point. So I'm going to take and plug in a 1 for the x. And when I do, I get negative 4e. All right, and now that's the exact answer. Right? That's the exact answer. And then the decimal approximation, if you wanted to know about what that was, you could take negative 4 and multiply it by e, find the e button on your calculator, raised to the first power, and that would wind up being around negative 10. Well, actually negative 11, negative 10.9, okay? So that particular function, if you were to graph it, you could take a look at where the tangent line hits the curve at an x of 1, and you should see that that tangent line should be falling and pretty steep. Okay? Both of those just said slope, so once we got the slope, that's where we stop. All right, now sometimes they ask you a little more than that, right? So here they're wanting the equation of the tangent line. So that means to get the equation of a line, I need the slope, and I can put it together then with this point. And if I need the slope, that means I need to do the derivative. Okay, so I'm going to do the derivative of h. Derivative of sine is cosine. Derivative of e, I just bring the constant and do the derivative of e to the t. Looks like I didn't do anything, but that is the derivative of that. Okay. And then once I've done that, I'm going to go on and look for what the value of the slope turned out to be. Okay, so I want to know what's the value of the slope when I put in pi. Okay, so now I'm going to come in here and get the slope at that point. So I'm going to plug in a pi. Okay, so the cosine pi is negative 1, right? Because pi is over here, and the coordinates of the point when you're over there are negative 1, 0, and the first one is your cosine. And then there's not a whole lot you can do to that. You just get that 1/2 e to the pi. E to the pi over 2 is also okay to write for that part. So that right there is your m. Okay, so that's your slope at pi. So now you know your slope is -1 plus 1/2 e to the pi, and the point you were given was the point pi 1/2 e to the pi. Okay. The only issue on this problem is that since the slope right here is not just a single number, this is going to look kind of weird. But I am really just doing that same process. It just feels so much harder because it's not just a nice number, nice easy number. Okay, and I don't want to put in pi and do e to the pi and round off. Okay, I want the actual equation of the tangent line. So I'm going to do y minus the y coordinate, put in the slope for m, and then put in pi for the x coordinate. Right. And then clean this up a little bit. So this one, sometimes when they're bad like this, the answers in the back of the book won't be in, they won't wind up having the answer looking like y equals mx plus b. Instead, they get it where everything's on the one side equal to 0. Okay. So I'm going to go ahead and just think of it as an mx plus b. So this is my slope. If I distributed it to these two, I would get -1 plus 1/2 e to the pi times x. And then when I distribute that to the pi, I'm going to go ahead and multiply the pi all the way through. And see how that's a negative pi? And I'm multiplying it by a -1, so that'll be plus pi. And then I'm going to do a negative pi times the positive 1/2, so I'll have a -1/2 pi e to the pi. Okay. All right, and then I'm going to add 1/2 positive 1/2 e to the pi to both sides. Somewhere over here, add 1/2 e to the pi. And I'm going to do that because, let me get another spot, because I am working on getting it in y equals mx plus b form. So here's y equals the slope. And then all of this, there are no like terms in it. All of that is my b value, really. So this is this, I'm going to leave it like that because that's my m, and then all of that is my b value. But I would take other forms if you had FOILed this out, okay, and written it in some other form, I would have taken that too. Okay. All right, now our next question is getting the points where you might have a horizontal tangent line. Okay. All right, so when I see that, I think tangent line. Okay, the slope of a tangent line is the derivative, and if I want to know where the tangent line would be horizontal, I need the slope to be 0. So I need slope, which is why I'm going to do y prime, which would be 1 plus cosine x. I want to know where the slope equals 0. Okay, that's what I'm being asked to do. So I'm going to take 1 plus cosine x and think about where does that equal 0. So I'm going to solve that equation. So cosine x would have to equal a -1. Look at your unit circle. Remember, cosine is the first coordinate, and I know right there would be the ordered pair -1, 0. That's pi. So I know when x equals pi, okay, or 3 pi, or 5 pi, or you could go the other way and have a negative, so it's at all of those. Now what they're typically going to do, I just didn't remember to put it on here, is they'll say determine the points, and they'll say on the interval from 0 to 2 pi. So they might write it using interval notation, or they might write it saying 0 is less than or equal to x, which is less than 2 pi. So they really mean on one rotation. And what that means is that I know that there's a lot of places where cosine would equal -1, but on the interval that's one rotation around, pi would be the only one. So at x equal pi, I know I would have a horizontal tangent line. Now, I need the points, the point. So that's the x. Now find y. Get the y coordinate. So go back to the original function, and you know it's going to have a horizontal tangent line when x equals pi. So plug in the pi. Okay, and the sine of pi is 0. And so it's going to have a horizontal tangent line at the point, an x being pi and the y being pi. So that would be the answer. The points where it has a horizontal tangent line would be pi, pi. Okay. All right, going to do one more. I guess that's it. All right, we want horizontal tangent line. So I know I need slopes, so I'm going to do the derivative. Okay. I know I need where y prime equals 0 to get a horizontal tangent line. So that means I'm setting this equal to 0 and solving. So I'm going to add 4 to both sides. And then I need to solve that exponential equation. These are some of the algebra skills that you're supposed to already know. So I'm trying to get you up to speed on it as we work through these. So remember how to undo an exponential function, how you took the natural log of both sides? So that's what you would do here. And the natural log of e to the x, since those two functions are inverses of one another, you get an x back out, and you know x at x equal ln of 4, at this point you know you're going to have a horizontal tangent line. All right, so far you know horizontal tangent line at x equals natural log of 4. So now you need the y coordinate. So you go back to your y equation, and where you see an x right there and right there, you're going to replace it with natural log of 4. Okay, so -4 natural log of 4, and then e raised to ln of 4. E and ln are inverses, so you're going to get 4 out when you do that. And so you wind up with the point, that's the x coordinate, right? So that goes there, natural log of 4, and then the y coordinate is this, which is -4 natural log of 4 plus 4. Okay, so there's the point where you're going to have a horizontal tangent line. Now, because of that negative there, you know, you might wind up seeing it written maybe a little cleaner if we just switched those two, made it 4 minus 4 ln 4. That says the same thing. So little things like that you need to be able to recognize. So that's the point where we're going to have a horizontal tangent line.